Thank you. I'm very glad to attend this NightLight workshop and meet so many experts around the world. My name is Liu Yang. I come from Ocean University of China. Our team focus on analyzing the nightlight image on fish activities. So today I would like to introduce one of our work, distinguishing multiple ocean-going fishing boats in the Northwest Pacific Ocean using nightlight image and AIS data. My presentation have 4 parts. Firstly, I will briefly introduce fisheries resource in the Northwest Pacific Ocean. This region is one of the most productive fishing ground in the world because it has the unique geographical conditions and the oceanographic properties. Here is the intersection of the 𝗖𝗂 current and the 𝗖𝗂 current. So in recent year, the capture production of this region has reached 20 million tons, accounting for 20% of the total marine fish production of the world. And in the West Pacific Ocean, the Pacific 𝗖𝗀, Neo flying squid, and chump mackerel are the major commercial fish species. Currently, these fisheries resources are being explored by China, Japan, Korea, Russia, Chinese Taipei, and Vanuatu. The main fishing method is using the light trapping. For example, this is the Pacific 𝗖𝗀 fishing boat here, and this is the night. In the night, there are a lot of light around this boat. So most 𝗖𝗀 fishing boat attracting and gathering Pacific 𝗖𝗀 with strong red light in the night. So this figure is the real picture photoed by my students. They are going on board to the in-situ survey. So after opening the red light, we can see in the ocean surface there are a lot of many 𝗖𝗀 near around the ship. So the production fluctuates every year, and the maximum can reach the 620,000 tons. Recently, it has been discussed to subject to quota management by NPFC. Therefore, monitoring multi-nightlight fishing boat plays an important role in protecting and utilizing fisheries resources, and also monitor illegal and unreported and unregulated fishing, and tracking the variation of the fishing ground. The development of satellite has provided effective detection method of identifying nightlight fishing boat. The ISNPP carried on visible infrared imaging radiometer suite was launched in 2011, which has the day-night bond with the ability of the low light detection. So the advantage of DNB image using for fishing activity, including they can cover the fishing time very same at the midnight, and also they can provide the daily global coverage and also the near real time. So that's a very useful data source. So how to distinguish 𝗖𝗰 boat from the multi-ocean-going fishing boat? We use two sources. One is the visible infrared imaging radimeter suit boat detection. We call it VBD. Another is the automatic identification system, AIS, boat detection. We call it ABD. So with the advantage of the NightLight fishing boat identification and the extraction technology, the DNB remote sensing data was increasingly utilized in various fisheries researches. On the other hand, the AIS data was also originally designed to communicate and boat identity. So compared to the DNB, the AIS data are not affected by weather, and the main information of the fishing boat contained in the AIS data. But AIS data also have some shortcomings, including the incomplete coverage and the error in maritime mobile service identity, and also the missing data and the deliberate suspension of signal transmission. So our objective is to develop an approach to distinguish the multi-fish species in the high seas of the Northwest Pacific using the ABD and the BBD, and also to create a comprehensive field NightLight fishing boat database that can combine the advantages of both VBD and the ABD for multi-species visual detection. This is the flowchart of the AIS data processing. I will simply to introduce. The first step is to select the target boat from the NPFC visual list. The next step is to sort fishing boat according to their visual type and the target species. And the final step is to distinguish the daily ABD from the AIS fishing effort data. The daily fishing position of the mackerel, 𝗖𝗰, and squid boat was selected based on the based on this MMSI matched with the NPFC list. Another is the VBD processing. So for each DNB images, the image pre-processing under the GLC, geometric correction, noise reduction, and radiance amplification. And according to the daily multi-ABD dataset, appropriate the thresholds were chosen separately in multi-VBD. To determine the range of the multiple VBD, also we use the focal statistic tool to calculate the largest SMI of the pixels within a specified neighborhood. Also, we use the ship radar image for the verification. Okay, let's see the result. This is the original AIS point, and this is our process by using the ABD processing method. We can see the blue is the squid boat, and the red color is the 𝗖𝗰 boat, and this green point is the mackerel boat. So we can divide the three species from the AIS data. And another is from the VBD. This is the NightLight image in this region in September 17th, 2018. So we can see there are a lot of group NightLight fishing. So from our approach, we can divide into the, for example, this right is the 𝗖𝗰 boat group. The green group is the squid fishing boat, and the blue one is the mackerel fishing boat. So this is the result, and then we process all daily number of the detected 𝗖𝗰 VBD and ABD data. So the blue one is the VBD from the NightLight image, and the orange one is the ABD from the AIS data. So we can see the number of the species specific fishing fleet detected using the VBD approach was larger than the ABD. And then we create the field NightLight fishing boat dataset combined with the VBD and the ABD. So the final result, we can see we can get a lot of information from the final result. For example, we can know the fishing period is from the May 5th until the November 27th. And also the period of the increasing fishing number is from May 5th until the September 4th. And also the most fishing period is during the August 14 until the November 18. This is very useful data. And we also process the monthly result. We can see the spatial distribution of the fishing boat in this region. And also we processed the trajectories. From the trajectories, we can see the 𝗖𝗰 fishing boat from the May to July is they are going to the north. And from the August to November, they are going to the southwest. So that's we can know the whole situation in this region. We proposed and developed a method to distinguish and monitor NightLight fishing boat targeting multi-fisheries in the Northwest Pacific using AIS and the DMB. And we think this approach can also provide a reference for identification of NightLight fishing boat in other oceans. Okay, thank you for listening. We wish this year the world will go to the normal, and everybody can visit Qingdao. We are in Qingdao, very beautiful city. Thank you so much.